In a room of 20 people, what is the probability that at least 2 of them have the same birthday? Assume a 365-day year. Well, it's theoretical probability. Notice the phrase, at least 2. So in terms of exactly, that means exactly 2 of them, or exactly 3, or exactly 4, or exactly 5, or tell me when you want me to stop, or exactly 6. Okay, because we'd have to go up to exactly 20. So we would have to add up 19 instances of at least 2, because we have 20 people here. We're not going to do that. Why? Way too much fun. Instead, what we're going to do is we're going to consider the complement. So the complement of at least 2 people having the same birthday is no one has the same birthday. We can't say at least 1 person has the same birthday because you need at least 2 to tango there. So if we find the probability that no one has the same birthday, and then subtract it from 1, or 100%, then that would be the probability that at least 2 people have the same birthday. Does everyone understand that logic? I'll say that again. So if we find the probability that no one shares the same birthday, and we subtract that from 1 or 100%, that would give us the probability that at least 2 people have the same birthday. Because the complement, the opposite, if you will, of no one having the same birthday is at least 2 people have the same birthday. So we're doing what I consider a backdoor approach. We're not doing it directly because we'd be here forever. Instead, we're going to assume no one has the same birthday. 100% or 1. So if we use a fraction or a decimal, we would use 1. Percentage, use 100. It's easier if we do a percent. As it turns out, we're only going to chip away at this fraction. What did I say? It's easier if we use a fraction. That's what I meant to say. Now we're better. All right. We're only going to start this out, but there's actually a formula going on here, which may seem familiar. So here's our table. Pretend that's 20 people. You'll get the hang of it out of a second. So our first person here, how many days can he or she pick to have a birthday? Assuming he or she picks his own birthday. How many? 365. Out of how many total days in the year under our assumption? 365. And this next person can't have the same birthday as the previous person. So how many days does he or she have to pick from? 364. And the next person can't have the same birthday as the previous 2, 363 over 365. Dot. Well, notice the denominator is always going to be 365. And we have 20 people, right? So if you multiplied all that out, that would be 365 to the 20th. Don't obviously do that in your calculator because it will explode. But notice in the numerator, we're going to have 365 times 364 times 363 times, and we're going to do this for a total of 20 times. Well, the numerator is a permutation of how many total days can we pick from, and how many total days are we picking? 20. So that fraction there represents the probability that no one has the same birthday. So how do we figure out the probability at least 2 people have the same birthday? We'll just take this fraction and subtract it from 1. So that says take the complement. So in your calculator you will write 1 minus, just to be safe, I'm going to use parentheses, 365 NPR 20 parentheses, divided by 365 to the 20th. You're going to get like what'd you get? 0.4114? Which is equal to 41.14%. So you have a 41.14% chance that at least 2 people in a room of 20 have the same birthday. Yeah. So anytime you're in a room, you ask the people what their birthday is? No. Okay, everyone shout out your birthday now. Yeah, sorry, the correct answer is April 12th. April 12th, yes. Yeah. Well, but just probabilistically speaking, that's how you would do this. How many people would you have to have in a room to guarantee that at least 2 people have the same birthday? 366.
Oh, really?
Yeah. Because the first 365 could each have their own birthday. So the next person has to have one of their birthdays.